Alright, pre-calc, this is part 1 of lesson 3-4. Basically in lesson 3-4 we're going to focus on solving two different types of equations. One type of an equation that would have roots and powers, and another part that would have fractions. We're going to focus in this video just on the roots and powers. So the first thing we always need to think about when we're solving these more complicated equations is the domain. We need to make sure that we eliminate any answers that wouldn't make sense. For example, if we have an even root, our answer couldn't be a negative value because we can't take an even root of a negative. And that is if we want to stay in the set of real numbers, which we are. The same thing, if we raise something to an even power, the answer couldn't be negative. So always check your answer, which is something we've been talking about. Make sure your answer makes sense and make sure it works. Alright, here's an example. So as first example, we have this quantity 5x. We're taking the cube root of that quantity 5x and we're getting the answer of 2. So we want to figure out what value of x would make this true. Well, just think of it, whenever we solve equations, we're undoing. To undo roots, we use powers. To undo powers, we use roots. So if we have a cube root, we can undo that with a third power. And then the other basic rule of equations is whatever we do to one side, we got to do the other. So this will undo, so we're left with whatever's under the radical, which is a 5x. And we get this answer here of 8. That's 2 to the third is 8. Now we have this very simple equation which we can solve. Divide by 5, and x is this quantity 8/5. And let's check. Let's see, if we take 5 times 8/5, that's our value for x, we would get 8, and then the cube root of 8 does equal 2. So that's a check. Alright, and then also thinking about the domain, our answer makes sense. It's within the domain with a cube root. We could have a positive or a negative value under that root. Alright, example 2. Again, we're dealing with an odd root, so the fact that we have an odd root and a negative answer is okay. That can happen. So we're just going to undo the fifth root with a fifth power. Whatever we do to one side, we're going to do the other. So this fifth power will undo that fifth root. We're left with the quantity 4x. Negative 3 to the fifth is going to result in a negative. And 3 to the fifth is 243. So now we have this equation that we need to solve, which is 4x equals negative 243. So we're going to divide by 4. So x will equal, it's not divisible, so it's just negative 243 over 4. And see how if we check that, 4 times that eliminates that denominator of 4. So we're left with the fifth root of negative 243, which is negative 3. But it does check. Okay, example 3 and 4. So we have, try to move this up a little bit. So for example 3, now this exponent that's a fraction, remember the top number is always a power, and the bottom number is always a root. So really what we want is x to the first. Since this is a fraction, to get that to be a 1, we want to multiply it by its reciprocal. In other words, we're going to undo that fifth power with a fifth root. We're going to undo that seventh root with a seventh power. So we're raising it to the power of 7/5 because rules of exponents, when we have a power of a power, we multiply those, any number times the reciprocal, that will give us x to the first, which is just x. Whatever we do to one side of the equation, we got to do the other. So our answer for x will be the 5th root of 243, and then that answer raised to the 7th power. Now you can do this on your calculator, but make sure you're very careful when you type this in your calculator. You're going to use your, I have a caret button. Make sure you put that quantity of 7/5 in parentheses, or else you'll end up with raising 243 to the 7th power and then dividing it by 5. So I'm going to calculate that on my calculator, and I get 2,187. So I can test this. What I'm saying is that 2,187 raised to the 5/7 power better equal 243. So I can check that. And it is in fact true, so that's a check. Now in example 4, notice how we have this x being raised to 3/2. The 5 is not being raised to 3/2. This is not, in other words, this is not equivalent to this. These are very different expressions. So we need to, in order to undo this power, we need to get rid of that multiplier of 5 first. So we're going to divide by 5, and then we'll undo the exponent. We're working in reverse order of operations. So we do that division on the right. We get negative 15,625. So now to undo this exponent, we're going to raise it to the 2nd power and take a cube root, which is a power of 2/3. And we get an answer of 625. And we can check that. And that should be a positive. So if we check this, we have a positive number being raised to a power and then multiplied by 5. This will never end up being negative. So if we go back and think about this domain in the beginning, we have a square root and then a 3rd power. The square root's never going to be negative. In other words, if we think about checking this answer, this would only end up being negative if the square root were negative, which, and then the 3rd power, so this actually will not even have a solution. Okay, so this example 4 had no solution because x cannot be a negative number. Let's go on to example 7, and I'm going to skip through to example 9. So in example 7, we have a square root. To undo that square root, we're going to use a 2nd power. And whatever we do it on one side, we must do the other. Notice the radical part is isolated. So we're going to raise the entire left side and the entire right side to the 2nd power. So this leaves us with x minus 2 on the right side. Remember, this binomial squared will give us 16 minus 8x. In other words, we're doing this multiplication. Plus x squared. So now to finish, we need to solve this, which is from our last lesson. So we want to get everything on the same side, get 0 on one side. So we'd end up with x squared minus 9x plus 18 equaling 0. In other words, I subtracted this x, which is where the 9x came from, and then I added 2. So now I have this trinomial equal to 0. So now to solve this, I'm going to use factoring. Okay, so this x squared minus 9x plus 18 equals 0 will factor into x minus 6 and x minus 3. Those are the two numbers that multiply to give us positive 18 but add to give us negative 9. So we'll get the solutions x equals 6 and x equals 3. And now remember, we can't have what's underneath this root being negative, and we need to make sure all of our answers are correct. So checking is extremely important here. So we're going to check both of these answers of 6 and 3. Alright, so we plug in 6, and we end up with negative 2 equaling 2, which is not true. So we would eliminate that answer. When we check 3, 1 does equal 1. That is a solution. I want you guys to try example 9, pause the video, and then check back to check your work. Alright, so you check your work on example 9. To get rid of that cube root, you had to raise the whole equation to the third power. So you end up with x on the left equals the quantity 2x minus 2. So we have this simple linear equation to solve. Subtract your x, and you get x equals 2. Check your work, make sure it makes this true, and it does make it true, so your answer is x equals 2.